I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
In this video, we're going to look at one variable inequalities. In order to do that, we need to first review the inequality symbols, which are less than, greater than, less than or equal to, and greater than or equal to. You need to make sure you know the difference in these very clearly and that you don't get them confused. So I have an example of an inequality here. 3x plus 4 minus 5x is greater than 12. So just real briefly, let's discuss the difference between an equation and an inequality. If I say x equals 3, then that means x is only one thing. It's just 3. If I say x is greater than 3, then that means x can be a number of different things. It could be 3.05, it could be 9, it could be 100. It can be anything that's bigger than 3. So when we're looking at inequalities, we're looking at an infinite number of solutions, whereas an equation has one solution. So that's kind of the big difference here. So we're going to solve this inequality very similar to how we would solve an equation, but we want to make sure that we pay attention to the inequality symbol as we solve. So the first thing I'm going to do is I'm going to combine my like terms. 3x and negative 5x is negative 2x. Keep my plus 4 is greater than 12. Then I'm going to subtract 4 from both sides. So negative 2x is greater than 8. 12 minus 4 is 8. And now I need to divide by negative 2. Now this is the main difference between equations and inequalities when you're solving. What I just did was I divided by a negative 2. Because I divided by a negative, this inequality symbol will flip. And now it becomes a less than. 8 divided by negative 2 is negative 4. So x is actually less than negative 4. So when you multiply or divide by a negative, you must flip the inequality symbol. Again, otherwise, this is just like solving a regular equation. Now, our final answer is x is less than negative 4. So again, that means there's an infinite number of solutions here. X could be negative 4.1, it could be negative 8, it could be negative 100. So we're going to graph x is less than negative 4 on this number line. And here's how we're going to do that. The first thing is we're going to identify where negative 4 is on the number line. And we need to figure out if x is equal to negative 4 or not. And when you look at this inequality, it's not. It's less than. So that means we're going to put an open circle at negative 4. We're not going to shade that in, meaning negative 4 is not a solution. And then we're going to draw an arrow where all the solutions are. So because it's less than, that's to the left. So this line represents all of the solutions to this inequality. And again, we have to say x is less than negative 4 because x could equal negative 4.0001. So it gets really close to negative 4, but it doesn't quite get to negative 4. And so that's why we have this open circle at negative 4. All right, we're going to solve 6 plus 2x is less than or equal to 5x plus 9. So the first thing I'm going to do is I'm going to subtract the 2x over. So 6 is less than or equal to 3x plus 9. And then I'm going to subtract the 9 over. 6 minus 9 is negative 3 is less than or equal to 3x. Solving for x, I'm going to divide by 3 on both sides. So that has left me with negative 1 is less than or equal to x. Now notice I did not divide by a negative. Okay, so we're really paying attention to this bottom number here. I divided a negative 3 by 3, but again, the negative 3 in the numerator does not dictate whether or not I flip my inequality symbol. It's the denominator that dictates that. So here's my inequality. Negative 1 is less than or equal to x. Now this can be confusing when the variable is not on the left side. So what you could do is you could rewrite this as x and then the negative 1 here, and you have to consider what symbol would go in between there. Well, if you look at this and read it backwards, we see that x is greater than or equal to negative 1. So those mean the same thing. Negative 1 is less than or equal to x is the same as x is greater than or equal to negative 1. And again, when we're trying to graph this, that's going to be easier to graph than the first one that we got. So x is greater than or equal to -1. So I'm going to put a circle at -1, but this time it's greater than or equal to, so it can equal -1. So this is going to get shaded in, meaning that is a solution. And then it's greater than, which is to the right of the number on the number line and anything past that. And so again, that line represents the solution set. There's an infinite number of solutions to this inequality. X can be an infinite number of things, anything bigger or equal to -1. So can x equal -1? Yes. Can x equal 2? Yes, because I can see that here. That is part of my solution set. So that's how you solve an inequality. And next we'll look at graphing and solving two variable inequalities.
I've been waiting way too long. Yeah. I've been down here trying to get it. Yeah. I've been waiting way too long.